Have you ever pondered how these minuscule silicon minds, our computers, can be challenged by the infinite universe? While our sophisticated technology may appear formidable in the grand scheme of things, the universe operates differently from our preconceived notions. Comparable to an enduring chess match in which the progression of the universe is perpetual, this scenario is replete with cosmic perils that may have far-reaching consequences for our computing systems. Commence by conceptualizing the immense magnitude of space. It truly is infinite. Mysterious it is. It is replete with phenomena that are beyond our most basic comprehension. Moreover, in the grand scheme of things, our technology, regardless of its level of advancement, is a mere particle of dust. Despite substantial advancements in the investigation of the cosmos, enigmatic phenomena persist in the incomprehensible depths of space, poised to test the capabilities of our silicon-based intellects. Consequently, what are these cosmic perils that endanger our computers? Let's find out together. Hello everyone, welcome back to Zeey. If you are new to the channel, hit the subscription button and ring the bell so you don't miss any of our daily videos. To begin, there are cosmic particles. These are high-energy particles from space that can disrupt computer operations by producing a cascade of secondary particles upon collision with the Earth's atmosphere. You will not, however, transform into a protagonist from a comic book if one strikes your laptop. Subsequently, there are solar flares, which are enormous discharges of energy emanating from the sun and capable of propagating electromagnetic waves towards Earth. The radiation has the potential to cause disruptions to electronic systems, particularly those located in outer space that are not shielded by the atmosphere of Earth. Finally, asteroids are present. Although not posing a direct danger to our computing devices, asteroidal impacts have the potential to generate electromagnetic pulses that may result in severe consequences for electronic systems. Currently, one may inquire, do our computers have no defense against these cosmic perils? It is not as simple of a response as one might assume. This perplexing cosmic dilemma necessitates further exploration of the enigmatic aspects of outer space and the durability of our technological systems. Therefore, let us delve into this cosmic paradox. Consider the impact of cosmic radiation, which are particles with an approach to the speed of light, on our computing systems. Doesn't that resemble the narrative of a science fiction novel? Nevertheless, this is not a work of fiction, rather it is an everyday reality. Cosmic rays, which are essentially high-energy particles that emanate from beyond Earth, have the potential to impact computer systems in manners that may not be readily apparent. Let's begin by examining the consequences that ensue when these particles enter our computing devices. They are capable of inducing a phenomenon referred to as a bit flip. Then define a bit reversal. In the realm of computer science, however, information is represented binary, consisting of ones and zeros. A bit flip occurs when this binary data is modified by a cosmic ray, which changes a 1 to a 0 or vice versa. It is as if, while composing a letter, every A is abruptly transformed into a B's. Things would begin to appear rather peculiar, wouldn't they? Consider this scenario as it pertains to a computer system. A bit flip may transform a line of code that is otherwise innocuous into an instruction that causes a system malfunction or worse. Furthermore, not only your personal computer is compromised. Constant temperature systems, such as those utilized in space exploration or aviation, are also vulnerable to these celestial interferences. Although they may appear to be an uncommon occurrence, bit flips occur more frequently than one might expect. Indeed, one bit flip per 256 megabytes of RAM per hour is estimated to occur on an area of 1 square kilometer along the Earth's surface. That is a substantial quantity of error potential, particularly for systems with substantial memory capacities. Bit shifts can have a wide spectrum of consequences, varying from minor software malfunctions to severe system failures. For example, a bit flip in the control system of a spacecraft could cause it to deviate from its intended course, or a bit flip in the computer of a hospital could result in inaccurate patient information. Real and potentially catastrophic effects of cosmic rays on our technology notwithstanding, do they represent the only danger posed by the universe? Solar flares, the sun's temper tantrums, can they really disrupt our digital lives? Solar flares are similar to how a toddler's outburst can disrupt an otherwise tranquil afternoon. They have the potential to cause significant damage to our digital environment. Solar flares are enormous solar explosions that propel high-velocity particles, energy, and light into space. They are among the most potent phenomena in our solar system. Electromagnetic disturbances can be generated when these high-energy particles interact with the Earth's magnetic field. These disturbances resemble imperceptible, silent cyclones that are raging in our atmosphere. These disruptions are capable of significantly affecting electronic systems, such as our devices. Contemporary society is profoundly influenced by digital technology. Our world is replete with electronic systems, ranging from the servers that fuel the internet to the smartphone that you carry in your pocket. Additionally, despite their advanced nature, these systems remain susceptible to the imperceptible and silent disturbances that arise from solar flares. The arrival of solar flare energy on Earth has the potential to induce an electrical surge within our power lines, thereby inducing power disruptions. Satellite damage can also result in the disruption of communication networks. It is also possible for our computers to be impacted. Envision an abrupt computer failure in which all unsaved work is lost. Or the failure of the data center that supplies power to your preferred online services. These situations are not merely hypothetical. In fact, such disruptions have been induced by solar flares in the past. However, you should not despair just yet. Although solar eruptions have the potential to disrupt our digital activities, such disruptions are not commonplace. Although these solar events are capricious, they do not transpire on a recurring basis. In most cases, we are provided with advance notice when this occurs, given that the particles they discharge do not immediately reach Earth. While solar flares do pose a silent yet formidable hazard to computer systems, the cosmos presents us with even greater obstacles. As our investigation of the cosmos progresses and our dependence on digital technology increases, it becomes increasingly vital that we comprehend these cosmic dangers. Therefore, in order to remain prepared for the next cosmic challenge, let us continue to learn and gaze upward. Could asteroids, which are invisible celestial projectiles, potentially endanger our computing systems? Undoubtedly, these celestial travelers in silence, asteroids, may seem incomparably distant from our realm of silicon and electronic circuits. Nevertheless, the investigation of their potential ramifications on our electronic infrastructure, such as computers, is a captivating topic. Let's begin with the fundamentals. Asteroids, which are rocky remnants that persisted during the nascent stages of solar system formation, are predominantly observed in the asteroid belt, a celestial region situated midway between Mars and Jupiter. Although the majority of them remain within this belt, a minority do indeed escape and approach Earth. Consider for the moment a sufficiently massive asteroid hurtling towards Earth. It would generate an enormous quantity of heat and pressure upon entering our atmosphere, resulting in a catastrophic explosion. In turn, this detonation would generate an electromagnetic pulse, or EMP, which is an abbreviation for an electromagnetic surge of energy. Electronic systems could potentially be severely disrupted by this EMP. The abrupt discharge of energy may result in circuit excess, leading to their eventual failure. In an era where machinery ranging from automobiles to coffee makers is controlled by computers, the ramifications of this situation are formidable to disregard. However, what are the probabilities that this will occur? Significant asteroid impacts with the Earth are, in fact, uncommon occurrences. NASA estimates that an asteroid the size of a football field strikes Earth approximately every 2,000 years. Conversely, smaller asteroids traverse our atmosphere with relative regularity. However, they disintegrate prior to impacting the Earth's surface. Thus, the risk that our processors would be damaged by an EMP triggered by an asteroid is relatively low. However, it is essential to remember that low risk does not equate to no risk. The universe is, in the grand scheme of things, replete with surprises and uncertainties. Despite notable advancements in the monitoring and forecasting of asteroid motion, there remains a substantial amount of knowledge that remains unknown. As our dependence on electronic systems continues to expand, it becomes ever more critical to comprehend and make appropriate preparations for these celestial hazards. While the threat from asteroids is relatively low, it is a cosmic hazard that we cannot completely ignore. How should our computer systems be safeguarded against these cosmic challenges? However, the solution can be found in a combination of novel approaches and conventional methods. Assemble an exploration of the realm of cosmic defense strategies pertaining to our reliable electronic companions. Isolation is one of the most prevalent methods to begin with. The impact of cosmic radiation can be substantially mitigated by encasing sensitive computer components in materials such as lead or other dense metals. However, there are limitations to this approach. It is less suitable for mobile devices and space equipment due to its increased weight. Additionally, particles with considerable energy can still breach these shields. Therefore, we arrive at our second barrier, which is error correction codes, ECC. ECC is a technique utilized to identify and rectify errors that may arise in the memory of a computer as a result of cosmic radiation. By including additional bits of data, it is possible to detect and rectify a bit reversal caused by a cosmic ray. This guarantees that our data will remain accurate despite being bombarded by extraterrestrial particles. Additionally, redundancy is a crucial tactic in the fight against cosmic radiation. The presence of multiple duplicates of critical components or systems enables us to bear the loss of one to a cosmic ray strike without incurring calamitous outcomes. Although it might appear excessive, redundancy is an essential safety measure in specific critical contexts such as nuclear power facilities or space missions. Finally, we must consider the future. Quantum computing and other emerging technologies hold the potential to provide unparalleled levels of resistance against cosmic radiation. By capitalizing on the peculiar and marvelous characteristics of quantum mechanics, these futuristic computers might possess an almost impervious nature to cosmic interference. However, bear in mind that no single solution applies to all situations. The optimal defense mechanism is contingent upon the particular demands of every system and the degree of peril it encounters from cosmic radiation. While the cosmos presents formidable challenges, human ingenuity continues to find ways to protect our computers and our digital lives. Furthermore, with the progression into the digital era, the significance of this cosmic defense will inevitably increase. Alright everyone, that is all for this video. Thanks for watching. If you are fascinated about space events, subscribe to our channel and ring the bell so you don't miss any of our daily videos.